Now, we want to look at the law of definite proportion. And this law is based on the concept that chemical compounds uh, has a constant composition or has a constant chemical composition either by weight or mass. For example, if I have, let's say, a compound of methane CH4, from our periodic table, we know that carbon has atomic mass of 12, while hydrogen has atomic mass is just 1. But from this composition now, you discover that in a pure sample of methane, if I have 12 grams of carbon, I'm going to have 4 times 1 grams of what? Hydrogen. I don't know if you can get that. We'll have 4 hydrogen here. You have 1 carbon in this place. So that means I'm going to have 4 hydrogen. If I have 12 grams of carbon, I'll have 4 grams of what? Of hydrogen. So that means 12 grams of carbon will give 4 grams of what? Hydrogen in a sample of methane. Now, let's say I have a sample of ethane C2H4. Now, from the periodic table, we have carbon to have atomic mass of 12 grams, hydrogen has atomic mass of just 1. Now, you discover from this place now, from this sample of ethane, it's a sample of ethane. So that if I have 2 times C, that is 2 times 12, that is 24 grams of carbon, I'm going to have 4 times 1, 4 grams of what? Hydrogen. So if I start to multiply something by 2 now, multiply something by 2. 2 times this, I'm going to have 48 grams of carbon. I'm going to have 8 grams of what? Hydrogen. It is going to be in this ratio. You start to divide now. If I divide this, I'm going to have if I divide this now, I'm going to have 6. If I divide it as well, I'll see I have 6. See? Then the definite proportion, they are the same. So 48 grams of carbon now in a tin, you have 8 grams of hydrogen and so on. What about, let's say we have a sample of CO2, carbon dioxide. So if I have 12 grams of from periodic table now, the atomic mass of carbon is 12, while the atomic mass of oxygen is 16. So in a pure sample of carbon dioxide now, 12, if I have 12 grams of carbon, I'm going to have 2 times 16 grams of what? That is 32 grams of oxygen. Because this one is O2, so O2 will be 32, which is something like 2 times 16, 32. Now, let's look at a typical question. If we have 30 grams of carbon, we have 30 grams of carbon. Okay, let's just look at for oxygen. If I have 30 grams of oxygen in a pure sample of carbon dioxide, how many grams of carbon is present? If I have 32 grams of oxygen in a pure sample of carbon dioxide, that is CO4, that is CO2, how many grams of oxygen is present? Now, what it said basically for in CO2, if you have CO2, it's carbon dioxide, if I'm having 12 grams of carbon, is equivalent to 32 grams of what? Oxygen. Now in this case, like I said, if I have 30 grams of oxygen, how many grams of carbon will be present? Now, S grams of carbon, that's for carbon, that's for oxygen. We have 30 grams of oxygen. The next, you just cross multiply. Let's look for S now. So X times this, we have 32X. 12 times 30, you have 12 times 30. What are you going to get? 12 times 30. If you do that, you're going to have a very lovely answer. It's 360. So let's divide both sides by 32. We cancel this. So X will become 360 divided by 32. And we're going to have what? We're going to have 11.25. That's what we're going to have as our answer. Now, we are going to have grams of carbon. Now, let me give you, if I give you this question now, if there are 30 grams of carbon in CO2, how many grams of oxygen will be there? How many grams of oxygen will be there? Can you solve this now? From definite or constant composition by mass, we have already established that for CO2, 12 grams of carbon. If we have 12 grams of carbon, we are going to have 32 grams of what? Oxygen. Now, 30 grams of carbon will now give us S grams of oxygen, because they say how many grams of oxygen will be there. So you just cross multiply. I just have two more examples to go and I'm done with this class. Just want to multiply. We're going to have S times 12, that is 12x. 30 times 32, we'll have 30 times 32. We'll have 960 divided by 12. Right, 12. S is going to be equal to 960 divided by 12. So we are going to have 80 grams of oxygen. That's what we're going to have. We'll have 80 grams of oxygen. So let me look at this question. Now, a pure sample of sodium fluoride. A pure sample of sodium fluoride contains 35 grams of sodium. Contains 35 grams of sodium. How many grams of fluorine is present? Contains 35 grams of sodium. How many grams of chlorine is what? Is present. Now, we have sodium fluorides to have this molecular formula. And from the periodic table, we know that sodium has atomic mass, that's what? 23. Then fluorine has atomic mass, that's what? 19. So that means if we have 23 grams of sodium, just look at this one, both of them are just 1. There's no one that is having 2 there. So if I have 23 grams of sodium, I'm going to have 19 grams of what? Fluorine. So in this proportion by mass now, we can say that if we have 23 grams of sodium in sodium fluoride, then 19 grams of fluorine will be there. But if I now have 35 grams now, from the question I say, how many grams of fluorine will be present if I have 35 grams? If I have 35 grams of sodium now, how many grams of fluorine will be there? So you cross multiply. Let's cross multiply. That is, we are going to have S times 23. That is 23. That is 23x equal to 35 times 19. 35 times 19. So 35 times 19, let's see what we're going to get from 35 times 19. So if you do that, 35 times 19, we're going to have 665. 665. Just have by 23. Just have by 22. Cancel this. S will be what? If you divide that by 23, we're going to have something like 28.9. 28.9 grams of fluorine. So if you have 35 grams of sodium, you're going to have 28.9 grams of what? Fluid. So that is from law of what? Constant composition or definite proportion. Last question for the day. Last question. If there are 45 grams of hydrogen in a pure sample of methane, if there are 45 grams of hydrogen in a pure sample of methane, how many grams of carbon is present? How many grams of carbon will be present? Already established that if you have CH4 from this place now, from the periodic table, we know that the atomic mass of carbon is what? It's 12. So if we have 12 grams of carbon, we have 12 grams of carbon, it's going to proportional to we're going to have 4 times, for carbon we have carbon 12, that is the atomic mass of carbon. The hydrogen is what? Just 1. So in this place now, but we have 4 hydrogen here, so I'm going to multiply 1 times 4, we have 4 grams of hydrogen. Now, how many grams of carbon, let's call that an S because we don't know that. How many grams of carbon we contains 45 grams of hydrogen? So that if because we already said if we have 12 grams of carbon in methane, I'm going to have 4 grams of what? Hydrogen. If I now have how many grams of carbon now will be corresponding to 45 grams of? So just multiply. So 12 times 45, S times 4. We have 4x is equals to 12 times 45. 12 times 45. I'm going to have 540. So divide both side by 4. Side by 4. You cancel this. S is going to give us 540 divided by 4. I'm going to have 135 grams carbon. That's what I'm going to have. So if you have 45 grams of hydrogen in the methane molecule, I'm going to have 135 grams of fluorine. 135 grams of carbon dioxide present there. Sorry about that. We're going to have 135 grams of what? Of carbon. Now I want to give you guys a take home. Just try and do this yourself and see if you can get the answer. Look at the question. Sorry, now before we look at the take home, let's look at this last question. If there are 19 grams of oxygen in a sample of aluminium oxide, this is the molecular formula for the aluminium oxide, a sample of aluminium oxide, how many grams of aluminium will be present? How many grams of aluminium will be what? Will be present. So how many grams of aluminium will be present? Now from this formula now, from periodic table, maybe you see in brackets equal to 27. That is the atomic mass of aluminium. Then O equal to 16. That is the atomic mass of oxygen. So if you want to check their proportion here now, you're going to get 2 times aluminium. That is 2 times for one sample of aluminium oxide. I'm going to have 2 times 27. That is 2 times 7, 14. 2 times 2, that is 4 plus 1. You're going to have 54 grams of aluminium present. Then for us, you have root 3. That's 3 times this 16 here. 3 times 16. That's why we're going to have 32 plus 16. 32 plus 16. That is going to give us 48 grams of oxygen. That's what I'm going to get. So in the proportion is that if I have 54 grams of aluminium, I'm going to have corresponding 48 grams of what? Oxygen in aluminium oxide. Now we are going to state it like just a normal proportion. If we have 54 grams of aluminium, it corresponds to 48 grams of what? Grams of oxygen. Now, how many grams of aluminium will now correspond to 19 grams of oxygen? That is the question we're actually looking at now. So let me just write it again. We said if there are something like 58 grams of aluminium, it will correspond to what? No, if there are 54 or 58, there are 54 grams of aluminium, it corresponds to 48 grams of what? Oxygen. Now, how many grams of aluminium will correspond to 19 grams of oxygen? Just want to apply this times this, we're going to have 48x is now equal to 19 times 54. 19 times 54. So what do you have? We have 1026. 1026. So divide both sides by 48. 48. So S becomes divided by 48. Divided by 48. We're going to have 21.375. Let me just say 21.4 grams of aluminium. That's what I'm going to have. Now, take this as a take home. Take this as a take home. If there are 42 grams, of hydrogen present in a pure sample of methane, if there are 42 grams of hydrogen present in a pure sample of methane, how many grams of carbon will be there? We are going to have 126 grams of carbon. So try and see if we can solve this and get the answer. I've solved almost example like this before. So we are going to have 126 grams of what? Of carbon. So please try and see. Try and do this to get the answer. So thank you. God bless you.